Hey guys, welcome back. This is number 6 in your angle proofs assignment. This is very, very similar to number 5. It's just that the given and the prove are backwards. Let me just double check, make sure I wrote this down right. I just had a panic attack. A, B, D, yep, C, B, E. Okay, good, got it. Just checking your assignment, making sure it's actually right. Okay. So instead of using the addition property of equality, we're going to use the subtraction property of equality in this one. Otherwise, it's pretty similar. So let's start off with our given as usual. Angle ABD is congruent to angle CBE. Okay. Let's take a look at our figure really quick. So we know that ABD, actually let's color code these really quick. So ABD looks like this. Okay. Is congruent to CBE. Okay, so the blue one is congruent to the red one. And they overlap a little bit. They both share angle 2. And so instead of starting with two small angles and proving that bigger angles are congruent, we're starting with 2 bigger angles and proving that 2 smaller angles are congruent. Once we have our first line here, I'm just going to translate this into equality, basically, using the definition of congruence. So if I have some congruent statement with angles, then my next move is to take the measure, take those angles and say that the measures are equal. And remember that my bridge between equality and congruence is the definition of congruence. If I know 2 things are congruent, I know their measurements are equal. Okay? And vice versa. So this is the next statement. Okay? Now from here, what we want to do is we want to say what this angle is equal to, or what angles add up to this angle. So we're going to use the segment addition postulate, the angle addition postulate, I did that in the last video too, to say what this is equal to. So I know the measure of angle ABD is equal to, let's look at our figure, ABD. That's the measure of angle 1 plus the measure of angle 2. Right? That's how I get the blue angle. I add the 2 little angles, angle 1 and angle 2. So measure of angle 1 plus measure of angle 2. Now remember, if we're in equality and we're adding stuff, we have to be using measurement. We can't be just saying the angle. We can't say angle 1 plus angle 2. That doesn't make sense to add 2 shapes together. What we want to add together is the measurement of those angles. Okay? So this is the angle addition postulate. Okay? Angle addition postulate says the big angle is equal to the sum of the 2 little angles that make it up. Okay, likewise, the measure of angle CBE, the red one, is equal to the measurement of angle 2 plus the measure of angle 3. And again, that's the angle addition postulate. Okay, so now what we're going to do is we're going to take this statement and we're going to rewrite it, but we're going to replace this with what it's equal to, and we're going to replace this with what it's equal to. All right, so measure of ABD is going to get replaced with, I'm going to need a little bit more room here, measure of angle 1 plus the measure of angle 2. All right, so I'm taking this statement, but instead of writing this, I'm writing this. Okay, equals. So on the right side of the equal sign, I would have this, but instead of writing that, I'm going to write these 2 angles, because that's what's equal to measure of angle CBE. So I have measure of angle 2 plus the measure of angle 3. Okay, and that's the substitution property of equality. Okay, so our next question is, how can we get just 1 and 3 by themselves? Like, how can you get measure of angle 1 equals to the measure of angle 3 only? Well, I can just subtract this from both sides, right? Because their measure of angle 2 is equal to itself. Obviously, that's a common notion, but it's also, we call that the reflexive property of equality. Okay, so I could do something like this. Minus measure of angle 2, minus measure of angle 2, cross it out, right? And that would leave me with just the measure of angle 1 on the left and the measure of angle 3 on the right. That's all that we have left. Now, of course, we don't write that part, right? We don't really show our work there. We just write the next statement in the chain. But what we're using there is the subtraction prop of equality. Okay, now we're pretty much where we want to go. The difference is this is equals and measurements, and we want angles and congruence. So we just got to switch back to congruence. Right? If the measures of two angles are equal, that means those angles are congruent. That's the definition of congruence. And we got it. So just the reverse of the other proof number 5. So hopefully that helps you guys out walking through these proofs. They're kind of fun if you think of it like a puzzle, right? And these, like, the only thing you can use is properties, and you try to put it together. It can be kind of interesting. If you're not, super comfortable with that, it can be sometimes a little bit stressful. So I'm trying to walk you through them as much as possible, compare things that are similar, get you used to the idea of, substitution and adding angles and stuff like that, because we're going to use those ideas more often. So embedded in some of these proofs are some common strategies and common ideas. And again, I've said this before, but the more you do, the more familiar this gets, the more comfortable it gets. We're trying to build those reasoning muscles, build those logic muscles, develop our intuition for proofs. So once you've seen many of these, when you see something that looks similar, you're like, I think I know how to do this. I think I'm going to use angle addition postulate. I think I'm going to use some properties of equality. I think I need substitution here. So check it out. Hopefully you can get this on your own, but if you can't, here's a walkthrough for you. Thanks.